Hello again to all my friends, my grade 7 students, parents, teachers, anyone else watching this video. This is our third video of our measurement units, measurement V3. We're going to be looking at area today, as we can see in these big blocked letters. And we're going to be looking at areas of rectangles, areas of squares, and areas of parallelograms. As always, it's Mr. Benjamin. I had a smiley face here, but it covered up, so I'm going to draw it again. Eyes and a mouth. There we go. So before we go any further, I really don't care about Carmen Sandiego, but I want to know where in the world is Miss Terrio? Again, she's not in the video, so what I need you guys to do, grade 7 students in Miss Terrio's class, please convince her to be a part of these videos, even if she's just going to be in a little bit. I really want her to join me in doing this. So we're going to recall perimeter. Perimeter is what we've been talking about for the last few days. Perimeter is the distance around an object. That object can be anything. It can be a square, circle, triangle. When drawing this, I thought this kind of looked like a fish, really, but we can still find the perimeter of this shape down here. All we have to do is take the measurement of each one of these sides and add them all together. We're not looking at perimeter anymore, we're going to be looking at area. And area is very similar to perimeter, but it's much different at the same time. So the area of an object is the measure of an object's surface. So while perimeter is looking at the distance around it, say for example if you were going to walk around a school or a house, that would be the perimeter, the area around it. But the area of the object itself is the surface, so this spot here. Everything that's colored in purple. Surface. And the area, unlike perimeter, the area, which we represent with A, the area is equal to the object's length times its width. So if we look at this square here, or this rectangle in this case, we recall that the length is the longer side. The width is the shorter side. So if we want to know the area, all of this here, we are going to multiply the length in purple times the width, which is in blue. We're going to look at regular shapes. So if we remember, regular shapes are anything with even and equal number of sides. So we've got our rectangle, we've got our parallelogram, and we've got our square. Now, each one of these is going to use a specific formula. So instead of having to measure each side, like we did for perimeter, we're only going to have to measure two sides of each one. And in the shape of the square, really only have to measure one side. So area, like we said, area is equal to an object's length times its width. So if we look at this square here, length and width, or this rectangle here, length and width. Now, the square is slightly different because all the sides are the same length. If we look at the area of the square specifically, it's just the side times 2, so the length times width. The rectangle, on the other hand, it's going to be two completely different numbers because it has its own length and width. For example, if this was, say, 5 centimeters and this was 2 centimeters, it would just be 5 times 2, which would equal 10. Before we go any further, we want to talk about the units. The units for area, it will be the unit of measure squared, which means it has a 2 above it. It's a superscript. It's not a subscript, it's above it. It's almost like an exponent. We can talk about that afterwards. But it could be meters squared, could be kilometers squared, could be any one of those, but as long as you have that 2 above it. The reason for that is we are covering a surface, not a distance. This is no longer a distance. We're now covering the surface. So again, all of this purple area. And the reason why it's squared is we actually make little squares around this. No, I'm joking. But just know that it's squared. So if we take an example of a square, our square down here, we've measured the side, and each side, we know because they're all equal, each side is 3 centimeters. So it doesn't matter which one you label as your length and width, could be any one. It's going to be the same thing. The area of the square is equal to length times width. So it's going to be equal to 3 times 3, and we're going to end up with 9 centimeters squared. So we're just going to write that all out again so we get the process down. The whole square is going to go. So we're going to take a square. It's pretty square shaped. And we're going to label our sides 3 centimeters. And we know all sides are the same. So area of the square is equal to the length times the width. In this case, both length and width are 3 centimeters. So 3 cm times 3 cm. And we're going to end up with 9 centimeters squared. Remember that unit. The rectangle, same idea, length and width. In this case, the length and width are going to be different numbers because it is a rectangle, not a square. And keep in mind that a square is a rectangle, but a rectangle is not a square. Don't worry about that, I just like saying that. So the area, always equal to length times width for a rectangle. We have 6 centimeters and 4 centimeters, so we write that out. And we have 24 square centimeters. Let's get rid of all this. And write it again. Area of our rectangle is equal to length times width. In this case, our length is 6, and our width is 4. 6 times 4 we know is 24. 24 squared centimeters, or centimeters square. So this distance here, or this surface area here, is 24 squared centimeters. Parallelogram is slightly different. It uses the same basic formula, but slightly different values and names. So instead of length times width, we're going to be looking at the base of the object times the height of the object. Now the way I remember these two is the base is always on the ground, so whatever's touching the lowest part. And the height, the way we find height, is we go at one corner or vertex, and we go straight down to the base. And we know that this is a right angle, and that kind of makes an H. So that's how I always remember it. That right there, a bit of an H. So that is our height, and the purple line is our base. So if we give these two some measurements, we're going to say that the height is 2 centimeters, and the base is, we'll call that 4.5 centimeters. We can finish our equation. So the area of our parallelogram is equal to base times height. The base is 4.5, and the height is 2 centimeters. When we do our multiplication, we know that is 9 centimeters squared. No, wait, that's way off, isn't it? No, that's not right. Let's erase that. Four and a half times 2, so 4 times 2 is 16, and that half times 2 should be 1. Let me just confirm that on my calculator. 4.5 times 2 equals 9. No, wait, that was right. Never mind. I don't know what I'm talking about right now. 9 centimeters squared. So ignore those last 10 seconds. 9 centimeters squared. Next time we're going to be looking at the area of a triangle and the area of a trapezoid. They have slightly different formulas, and there's a bit more work involved, so they're going to have their own lesson. I'm going to say thanks for watching. We're going to have a quiz on Friday. Keep that in mind. I'm going to leave you with a little bit of a tornado here. That's really fun to do and really fun to draw. You should try it yourselves. But I'm also going to give you a few practice questions. So that's going to be on the next page. So find the area. So let's get that and that. And I will draw out the base and height for you. Remember that little H? Kind of looks like an H. That's our height, and our base is down here. So let's call this 4 centimeters. Call this 3 centimeters. For our square and rectangle, this can be we're going to call this 2 kilometers. We're going to be a little different. And each side is the same. And let's make this 3 meters and 6 meters. Alright, so give these a try. Make sure you have these done for tomorrow's class. And keep in mind, homework quizzes can happen, right? Okay, so now, really, the end. Big smiley face. Later.